Alright class, today we're going to do a little bit of review from factoring, your favorite thing to do. Like I said, we'll do this a lot, so you'll get good at this as we keep going. First thing you should always do is look for a GCF. I noticed that every number can be taken out, 4 can be taken out of it, and you can take at least an x squared out of everything. So I'm going to take out a 4x squared, and when I divide that out of there, I'm left with a 4x cubed. I'm left with a 3x squared. 4 to 20 is 5. X, and then when you divide a 4x squared plus a 4x squared, do not forget to put the 1 there. Some of you guys just say it's gone, nothing there. This one here is just our normal factoring, two numbers that multiply to 60 and add to negative 17. And again, if you want to pause this video and try a bunch of these on the front page to see if you remember how to do them, it'd be a good practice. Actually, I would recommend you do that. 60 is 15 and 4. That doesn't help us, but 5 and 12 does. So minus 5 minus 12 gives us minus 17. Alright, Batman on splitting the middle term or guess and check. Again, you can do either method. Since there's a 2 here, that should be a 1 and a 2. And usually with these, it's going to be a 5 and a 3. So I'm going to just double check what I get right now with these two things. I get a 3x and a 10x. That's not going to get me anywhere with an x in the middle. So I'm going to change these numbers. And now I have a 5x and a 6x. Good. So that will get me a 1 if one of them is negative. I need the 5 to be negative. This needs to be negative to add to positive 1. So if that's the case, that means that in order for that to be negative, this has to be negative, this has to be positive. So my final answer is 3x minus 1 and 5x plus 2. Again, I just use guess and check. A perfect square trinomial, we looked at this yesterday. We FOILed these out. This looks like this is 4 squared, which is b, so b is going to be 4. This looks like it's 3x squared. So a is going to be 3, so I'm going to, or 3x. So I'm going to say that this is 3x plus 4 squared. Now you can test it by multiplying a and b together. A times b is 12 times 2 is 24x. So we're good there. This is our difference of squares, so we have to get this down to the conjugate pair. And there it is. And what do we know about sum of squares? Is that a thing? No, you cannot factor it. We also say that it's prime. Okay? Alright, so the new ones we're doing. We have factoring by grouping and then sum and difference of cubes. Grouping is basically when we did the splitting the middle term method. You did grouping when you had the 4 pieces and you did the 2 and the 2. So for grouping, you look at these two and these two. And you do a GCF for each. So I'm going to look at just the red grouping and say, okay, I could pull an x squared out of there. I'm going to look at the purple grouping and say I could pull a positive 9 out of there. Factoring by grouping only works if these match. And in this case they do. So our final answer is we take one of those and then we take the outside pieces. And then that's our final answer. Because we cannot factor x squared plus 9 any further. Let's try it again. Again, you can now pause the video if you want to try it on your own first. Out of this first grouping, I can take a 4 and an x squared, and that leaves me with a 3x minus 2. Here, be careful. It looks similar to what we have, but we need to get it to look like a 3x minus 2, so I have to take out the negative 1. And here's how you know that works. If you multiply a negative 1 back in, you'll get a minus 3x plus 2. So now that works. We have these outside pieces, or inside pieces, are 3x minus 2. We have these outside pieces as 4x squared minus 1. But then you have to look at it and go, wait a minute, is this a difference of squares pattern? Yes, it is. So our final problem, our final answer is, we can break this down using our conjugate pair, because 1 is always the square root of 1 is always 1. So that's my final answer for that problem. Alright, so now this is the new one. Sum and difference of cubes. You will need to remember this. This is different than when we multiplied something by itself 3 times. We're not doing that. We have two things that you can cube root, and there's a way to factor them. And you can do sum or difference. The only difference is, if it's a sum, this is positive, this is negative. If it's a difference, this is negative, this is positive. That's the only difference there. So let's try this with the pattern. What's being cubed here? Well, a is equal to x, and b is equal to 3, because 3 cubed, right? So now that I know what my a and b are, I can follow this pattern. The answer is a plus b, so x plus 3, a squared, which is x squared, minus a times b, which is 3x, plus 3 squared, which is 9. That's the answer. You can never, ever if you do sum or difference of cubes, this piece will never be factorable, the second piece. So you're pretty much done once you do that. Okay, we have to figure out what a is here. 8, what cubed is 8? It's 2 and x. So my a is equal to 2x, my b is equal to 1. And it's a minus sign, so we're going to use this pattern. So it's 2x minus 1. 2x quantity squared, be careful. You have to square both pieces, it's 4x squared. Plus 1 times 2x is 2x plus 1. And that's the answer. Alright, let's review some other ones. This was right off of a test. I feel like you had one on a test like this from unit 1. It's the same as just normal factoring, numbers that multiply to 27 that add to negative 12. They both have to be negative, and instead of x and x, we have they're both x squareds. And then you check to see if there's anything you can do, and yes, sure enough, we have a conjugate pair here, and we can do this. Good. And that's it. Here, we look for a GCF to pull out first. I can pull us x squared out, and I can pull, it looks like a 2 out. And now some of you guys would be like, oh, I'm done. But you're not done, because now we know how to factor this, because this is a difference of two things that are being cubed. So we could rewrite this, or we can say that this is the same thing as 2x to the third, and this piece is 5 to the third. So that means that for this problem, a is going to equal 2x, and b is going to equal 5, and it's going to be the minus 1, so the minus will come first. So we still have the 2x squared out here, but now we're going to factor this thing. So we have a minus b, a squared, plus a times b, plus b squared. And again, that was using the difference of cubes. Okay? So that's the final answer for that one. Again, we need a GCF. This problem, I can take an x out and a 2 out, and I'm left with an 18x squared plus 9x minus 20. Now again, you can either do Batman or guess and check. Batman would be big numbers, but so would guess and check. I'm going to guess that for a 20, I'm going to do a 5 and a 4. And for 18, I'm going to guess maybe a 6 and a 3. Let's see where I'm at with this. 15x and 24x. Can I get a 9 out of this? Oh, I can get a 9 out of this if the 15 is negative, because 24 minus 15 is 9. So that means that there has to be a minus sign here and a plus sign there. So that was a good guess. And then 2x. So that is the final answer for that. Again, you could have done splitting the middle term as well. Again, GCF, I can take a 3 out of both those numbers. I can take an x squared and a y cubed. So 3x squared y cubed. And what I'm left with is a 64x cubed plus 27. And again, when you see a cube like that and look at those numbers, you have to think that might be a sum of cubes. And sure enough, my a value is 4x, because when you cube 4 you get 64. And here we have 3 cubed. So my a is equal to 4x, my b is equal to 3, and I'm going to use the pattern a plus b. So first of all, we still have this thing out here, a plus b. A squared, which is 4 times 4x times 4x is 16x squared, minus, so now with the plus factorization we have the minus over here. 4 times 3 is 12x, and then finally add 9, because 3 squared is 9. So that is the complete factorization of that problem right there. So GCF and then look for patterns. Okay? Alright, good. That's it for today.